All right, so in the AI world, there's this massive battle going on. I mean, a real clash of titans. It's all about how we give our models context. You've got two main camps. In one corner, there's the super organized, methodical approach we call RAG, that's Retrieval-Augmented Generation. And in the other corner, you've got the raw power, the brute force memory of long context windows. Today, we're going to dig into the money side of things, the tokenomics of this whole showdown. And this is the quote that basically lit a match in the AI community. Vectors are lossy. Long context is perfect recall. You could save $500 a month just by deleting your vector DB. I mean, come on. The idea that you can just trash your entire complex RAG setup, save a bunch of cash, and get better results, it sounds incredible. Maybe a little too good to be true. So, you know what? That's what we're here to figure out. Okay, to make sense of all this, let's paint a picture. Imagine RAG is like a perfectly organized, super smart library. The librarian doesn't have every book memorized, but they have this flawless card catalog, that's our vector index, that can find the exact sentence you need from 1,000,000 books in a split second. Now, long context, that's a whole different beast. It's like a genius with a true photographic memory. You don't need a library at all. You just hand them an entire encyclopedia, and they remember everything, word for word. So, that's the big question, isn't it? Can the genius really replace the entire library? Is that $500 promise for real? Let's dig in. All right, first up, let's get to know the genius. We got to understand just how powerful these new long context models are, because honestly, they're a total game changer. And when we talk about power, what's the scale we're even dealing with here? Well, models like Google's Gemini 1.5 Pro can cram up to 10 million tokens into their context window. Just to put that in perspective, that's not just one book. That's a whole bookshelf. It's hours and hours of video. It's a massive code base, all held in active memory at the same time. It is a truly mind-boggling amount of data. So, that's great and all, but how do we know the model is actually paying attention to all that information? Well, we test it. And the go-to benchmark for this is what everyone calls the needle in a haystack test. It's pretty much what it sounds like. Researchers will hide one tiny, specific fact, that's the needle, inside a gigantic pile of random text, the haystack. Then they just ask the model, hey, can you find this for me? And honestly, the results are just wow. Gemini 1.5 Pro has shown it can find that needle with near-perfect recall, almost every single time, even when the haystack is 1,000,000 tokens deep. Think about this. You can give it the entire novel Les Miserables, all 710,000 tokens of it, and then ask it these really deep, complex questions about a character's journey from beginning to end, and it just answers them. It really does look like the genius has a flawless memory.
But hold on, let's not tear down the library just yet. Our trusty RAG system, it's been the king of the hill for a reason, and trust me, it's not ready to give up its crown.
So just a super quick recap on how RAG actually works, right? You take all your data, you chop it up into smaller manageable pieces or chunks. Then you turn each of those chunks into a string of numbers. That's your vector embedding. All those vectors get stored in a special vector database. So when a user asks something, you don't send the whole library to the AI. No way. You just find the most relevant couple of pages and feed only those to the model. Super targeted, super efficient.
Now this is where it gets really interesting, because this gets right back to that hook from the beginning. See, when you turn text into a vector, you're doing something called lossy compression. You're squeezing a whole paragraph down into a list of numbers. And just like when you compress an image too much, you lose some of the detail. Some of the nuance gets lost forever. And that is the exact weakness the Genius model says it can fix.
Okay, let's talk money. Is that $500 a month figure real? Well, yeah, it absolutely can be. Running a proper vector database isn't free. You look at providers like Weaviate or Pinecone, and yeah, they might start at $25 or $50 a month, but for any real-world enterprise-level application, oh yeah, that number can shoot up into the hundreds, even thousands real fast. So the idea of just wiping that bill off the books is pretty tempting.
But here's the thing. The library isn't just sitting there collecting dust. It's getting smarter. The database companies are coming up with cool new tricks like multi-tier storage. The idea is, you keep the stuff you need all the time on super fast, expensive, hot storage, and the stuff you rarely touch gets moved to cheaper, cold storage. But even bigger than that is this shift in thinking. People are starting to realize RAG isn't a competitor to long context, it's a collaborator. You can use RAG as a cheap, smart filter to find the right documents before you hand them over to the expensive, Genius model to read.
And this is where the story takes a twist. We've been talking about the genius's amazing perfect recall. But what if it's not so perfect after all? What happens when you find cracks in that perfect memory?
So, let's just ask it straight up. Is long context recall truly perfect? And according to the latest research, the answer is a big, fat no. And this chart just lays it all out there. This is a failure analysis for Gemini 1.5 Pro. Just look at all that blue. You know what that represents? It's not the model refusing to answer. It's not the model crashing. It's the model giving a flat-out wrong answer. The genius isn't just making mistakes, it's being confidently wrong. And that's a huge problem.
And we're not talking about tiny little slip-ups here. Look at these examples. The model was given the correct answer in the text, and it still messed up. It got the inventor of the Transcontinental Railroad wrong. It got the longest-serving chief minister in India wrong. It even got the winner of America's Next Top Model wrong. It turns out even a photographic memory can get fuzzy.
So here's where we stand. We have a genius who's incredibly smart, but sometimes makes things up, and we have a library that's super precise, but maybe a little lossy. It's time for the final showdown, library versus genius. Let's break down the cost and the accuracy.
So let's circle all the way back to that $500 promise. Can you really save that much by just deleting your vector DB? The answer is maybe. It's not a lie, but it's definitely not a universal truth. For some projects, yeah, for sure. For others, it could be a really expensive mistake. It is, ironically, all about the context.
Let's put up the final scoreboard. On one side, you have RAG, our library. It's your go-to for finding that one specific fact in a massive ocean of data. The downside? It's a bit of a pain to set up, and you've always got that lossy vector problem. Then you have long context, the genius. It's brilliant for really deep thinking across a whole bunch of documents you give it. The weaknesses? Well, the paper token cost can get crazy expensive real fast. And as we just saw, it can be confidently wrong, which is kind of scary.
So, what's next? Where do we go from here in this clash between libraries and geniuses? You know, the key takeaway here is that we've been asking the wrong question all along. It's not about which one is better. It's about seeing them as two different tools in your toolbox. And you know what? They often work best together. Think about it. Use the super efficient library, RAG, to find the 5 most relevant books from a collection of 1 million. Then hand only those 5 books to the genius, the long context model, for a deep, thoughtful analysis. That hybrid approach, that's where you get the best of both worlds, the cost savings of RAG and the incredible reasoning power of long context.
So in the end, it all comes back to what you're building. Do you need a library that can find one tiny fact in a sea of information? Or do you need a genius who can read 100 pages and tell you what they all mean together? But really, the biggest question you have to ask yourself is about trust. Which system, or which combination of systems, are your users actually going to trust to give them the right answer? Because that's the only thing that really matters.